So before good water was delivered to New York, they relied on streams and wells that were dug just in the general area. They had a few very small streams and one pond.
Tom, I've got two more people for your tour.
Okay.
He's been on it before, but he rides like that.
Oh, okay.
So good.
All right.
And before it was me that did it, so you've got to be as good as I am.
Oh, I don't know, Sarah. That's a pretty tall order. In 1834, New York City was suffering with really bad water, and they had since after the Revolutionary War, when cities were very small, maybe 50,000 people, because of the Revolutionary War spreading people out of the city. Most of the city was burned down by arson or other military action during the war. And so the population had grown by 1834 up to about 300,000, very quickly. The Erie Canal had a lot to do with it. A canal across the entire state of New York, from Lake Erie all the way to the Hudson, which allowed products that had produced in the country, farm products and manufactured products, furs, you name it, to be delivered to New York City. So it was becoming a big center of commerce and surpassing Philadelphia in size. But the 300,000 people of New York in 1834 were still drinking the same foul water they had drank 40 years before, 50 years before. And as I just told these folks, 3,000 people died in the summer of 1834 from cholera, a newly introduced disease. It was basically a disease transmitted by polluted water. And New York had only, for the early settlers, the Dutch and the English after that, a few ponds and streams and wells that were dug all around down into the sand underlying soil and sand around New York. They couldn't dig them too close to the East River or the Hudson River because they would be saline. And in fact, they had withdrawn so much of the fresh water from New York that a lot of the well water, even in around the area where Foley Square is now, and where there was a pond, was becoming saline as well, drawing in the ocean water, the bay water, into the formerly fresh water. So by 1836, New Yorkers understood that there was really no alternative but to find a supply of fresh. They called it pure and wholesome water. And after many years of argument, debate, surveys by engineers, crackpot ideas about damming the Hudson River, which is a tidal river which flows both ways, so damming it would be a ridiculous idea. They decided the Croton River in northern Westchester would be the source because it had enough of a guaranteed flow to provide 70 or 80 million gallons a day on a regular basis. So even though it was 41 miles from the city, the voters voted 2-1 in a local, I guess you would call it now a plebiscite, to invest as much as $5 or $6 million. And for a city of 300,000 people in 1836, that was a huge amount of money. By 1837, it was under construction. By 1842, it was complete. This tunnel that we're going to look at right now, the brick-lined tunnel, was in operation in 1842 and relieved a lot of the polluted water pressures that had caused disease in the past. I'd like to read you one little quote before we go downstairs. Hi, come on in. It's cool in here. And now you're cool. There was an engineer who worked on the Croton project named Fayette Bartholomew Tower. And he worked for the 5 or 6 years that it took to build the aqueduct. He was a lieutenant of John B. Jervis, the chief engineer. And in writing a letter to his girlfriend on July 8, 1842, a letter that in its original form survives at the New York Public Library. And I'll get around to the coincidence of that in a moment. But in July 8th, he describes the letting in of the water into the distributing reservoir for the first time on July 4th. This is 4 days later. And he says to his paramour, his intended, his girlfriend, "At an hour when the morning guns have aroused but few from their dreamy slumbers, and ere yet the rays of the sun had gilded the city domes, I stood upon the topmost wall of this reservoir, and saw the first gush of the waters as they entered the bottom, and wandered about, as if each particle had consciousness, and would choose for itself a resting place in this palace, to which it had made a pilgrimage. Or I fancied I could recognize the water nymphs of the Croton, coming from their rugged caverns to enjoy the refinements of the city residents." Pretty poetic for a guy in 1842. but you have to remember that he was writing to his girlfriend as well. And I think it's pretty impressive. And you get kind of a picture of the city that was a sleepy, quiet little place where not a lot of activity or not a lot of noise. Talking about the sun gilding the domes, like a church or another fancy government building, and making the dome look like it had been lit up by the sun. So that was his first impression, and many people's first impression of the water. The coincidence of the letter is that the distributing reservoir he was describing was on the corner of 42nd Street and 5th Avenue, where the New York Public Library now stands. So it was an above-ground reservoir that distributed water to the south, another mile to the south of 14th Street and below, where the city actually was. In 1842, the distributing reservoir was still a mile above the established city, and all the blocks had not yet been filled in with buildings, and in fact, even streets had not been laid out as far north as 42nd Street. So when you think of New York as this, huge metropolis now, it was somewhat less huge in 1842. The Fountain Reservoir, which they refer to the original reservoir in Croton as the Fountain Reservoir, was confined behind a 50-foot high dam. And this is a picture of it in the 1950s, the last time it was exposed by low water in the New Croton Reservoir. Normally it's under 30 feet of water, as it is now. So it's an underwater historic landmark, but you can't see it. Sorry. We'll show you some more photos as we go down. But one of the original drawings, F.B. Tower was also an illustrator and wrote a book in 1842. He didn't just write a letter to his girlfriend. And one of the illustrations in it is of the double arched bridge here in Ossining. Look at the picture of it in here somewhere. So you know what? I mean, I'm having this.
Tom is just starting this tour.
Hi.
So you
Come on in.
Thank you. He misled them. No, he misunderstood. And sent them down the Sing Sing Hill, and they kept looking for the aqueduct.
That's where?
Because Sing Sing Hill, I know where the aqueduct is. I was looking for the tour guide. The tour guide, Here he is. Right, thank you.
The aqueduct was built mostly by itinerant Irish laborers who were just coming off the ships from Ireland. In the 1830s, the potato famine had not yet hit. That wasn't until 1848. But the Irish were still escaping Ireland because of the oppression of the British, because they were starving peasants who had no opportunities, and they thought that America would be a better place to be. So most of the pick and shovel work was done by Irish immigrants, right off the boat and willing to work for $1 or even 75 cents a day. Some of the skilled labor were early surveyors, and they had equipment then, like a surveying system. Hey, how you doing? It was pretty, elaborate and well built, even for its time in the early 19th century. Another skilled laborer was a mason, who basically hand-cut stones with a hammer and chisel. I don't know if any of you have tried to swing a 5-pound hammer all day, but I did try it, and it lasted about 5 minutes. You need an arm of iron to wield a hammer like this all day, chipping away little bits of stone so you get a block cut to very specific dimensions. But the majority of the workers were these itinerant Irish, what we would call today hobos, from Ireland. And this is a photograph from the historic Hudson Valley. They have a library of illustrations. They found this one depicting actually a component of the aqueduct behind them. And he would have been just a guy off the boat who could handle a pick and shovel and do some stonework. Oh, I don't want to skip this one. It's here. Here's the double arch bridge as it appeared in 1842. The secondary bridge underneath it, which is a wooden trestle at the time, and this one has been colorized, but the illustration is by F.B. Tower, the gentleman whose excerpt I read of his letter. And there are about 15 or 20 illustrations in the book he wrote called Illustrations of the Croton Aqueduct. It's worth looking up online if you want to see it, and you'll get a much better description of the entire aqueduct and its components. and what it meant to the city at the time. There's also an excellent introduction in the book about the ancient Roman aqueducts and how this one was based on the same physical and engineering principles as the ancient Romans. Basically a gravity-driven system that would allow the water to go downhill on its own without any pumps or any mechanical contrivances. And so the engineers who built the Croton Aqueduct were just copying the ancient Romans because their system worked 2,000 years ago and nobody had come up with a better idea since. And it avoided the use of expensive pumping equipment at the time, which would have been big steam engines and unreliable machinery that would break down. Philadelphia was the first city to have a pumped system from the river going through the town, and occasionally their steam engines would blow up with, drastic effects, and use amazing amounts of coal in the process. Another component was the high bridge. Oh, you can just leave that there. It's okay.
For my tour. I need for my tour. I got the next one.
The High Bridge, which is the oldest standing bridge connecting Manhattan to the mainland. This is a depiction of it in the 1840s or 50s when it was recently built. And it basically connects the High Bridge neighborhood of New York with Washington Heights in Manhattan. It was recently renovated and reopened to the public, and you can now walk across this bridge today in its slightly modified form. And here's a picture of it maybe 10 years after it was built, showing a couple of men on the Aqueduct Trail on the Manhattan side, in between that rock cut, which still exists.
The water pipe is right in here. I find that hard to understand.
Oh, in the top row of the building, yeah.
This is where the water went, and I just think, how did this big brick tunnel of water get into that?
They used metal iron pipes across the High Bridge. So for the short distance, 1,400 feet or so, from the brick aqueduct on the Bronx side to the Manhattan side, they condensed it into pressurized pipes, iron pipes. And there were two 36-inch pipes, basically, that supplied all of New York City's
For
water.
a few more people, like 4 minutes on your tour.
We'll start downstairs. I'll continue my jabbering down there. And you can start a new one up here.
Oh, I
How
can
about
start
that?
a new one. Okay.
Yeah, I think that's the way to do it.
Okay, okay.
So anyway, this is
Are you guys done, neighbors? Okay, so okay, so if you want to get out,
Here's the 42nd Street Reservoir where the New York Public Library now stands. And this is the reservoir Anthony Tyler was talking about when he wrote his letter to his girlfriend. The public could enter and walk around the perimeter of it on top. It's fenced in as like a public observation deck. And so that's what he was talking about. Even Walt Whitman wrote about it back in the 1870s and 80s.
You can see all the smokestacks in the background.
It's like a big swimming pool.
The what?
The smokestacks in the background, all the smoke rising up.
Yes, everything was fired by coal in those days.
Yeah.
So any buildings that were built around the
we're going to go
reservoir.
downstairs so the next tour can start.
I will.
You got to do it right now.
I better. Walk this way. This is a mechanism built in the 1880s for this particular weir, which is an additional add-on to the aqueduct, which allows a little more finely tuned draining and filling up of the aqueduct tunnel. This is attached to a gate down there, about a 6-foot high gate. It can be raised and lowered to let the water in the aqueduct out into the Sing Sing Hill below the bridge. And then repairmen and inspectors who come in and inspect the tunnel to make sure everything is repaired. And there's another gate in back of you, larger that prevent the water from going south. So hold on to the railing, especially if you have any lug soles on your shoes, they can get caught in the metal radius. So just be careful as you approach. So, 55 degrees. It stays this far below ground. Once you get about 10 feet underground, the temperature is always 55 degrees. Winter and summer. In the summer we can down here get cool, and in the winter we go down here warm. It's not a sewer, but an aqueduct. The water that you drink is go through this.
Do we those big reservoirs we used to have?
Yeah, sewers look like this too, but they have the water after it's been used.
The dirty
Yeah,
water, this is the clean water.
and also they don't have the entrance for them usually.
Okay, as you look upstream, you're looking in the northerly direction from which the water came, and the aqueduct was basically built 7.5 feet wide, 8.5 feet high, with a slightly concave floor, which is not perfectly obvious, except if you look under the grating, you can see it a little deeper in the middle where the seepage is flowing. Originally, they reinforced it only to about the height of 5 feet on the outside of it. Right in back of you can see some of that stonework that extends out about another 2 feet. Just laterally. And that would have reinforced the bottom half of it with the pressure of the water pushing against it as it flowed south. Covering anything above that was just covering to keep debris and anything falling into it, the stray deer or whatever who might fall into the aqueduct on the surface. It's just lined with 2 layers of brick, although here you can see 4 because they added 2 more layers right here when they built the weir. But originally the thickness of the arch was only 2 bricks thick. And the water was only supposed to reach as high as the spring of the arch, which is about 5 feet from the bottom. And that would be enough by design to supply as much as 70 million gallons a day to New York City anytime after 1842. So once the water came into the city and word spread that people who were paying for the water from the Road and Aqueduct Department were not getting cholera, then everybody signed up for drinking water. And very, very quickly, between 1842 and 1870, the demand for water rose so quickly that by 1870 they were letting water into within 12 inches of the ceiling of the aqueduct. It wasn't built for that, and it caused problems with cracking and pressure of the water inside leaking and causing all kinds of problems. So there was constant maintenance for a good 30, well actually until 1890, when the new program was opened and delivered water through a bigger, more robust tunnel, 3 times the amount of water that came through this one. So they continued delivering 100 million gallons a day from 1870 to about 1890. And then, as soon as they could, they lowered the level back down to 70 or 80 million gallons a day. They would occasionally discover leaks on the portions of the aqueduct closer to the surface. Some places where the ground falls away, it's built actually above the surface, and then just mounded over with about 3 feet of earth. And occasionally, where there was a leak, they would find water squirting out the side of the aqueduct. And the maintenance men, or the superintendents, who were placed about every 8 or 10 miles along the aqueduct, it was their daily responsibility to patrol it and make minor repairs. Because it would take about 2 days to drain the aqueduct, go in and patch a crack, they figured out other ways to do it without shutting down the aqueduct. They would go upstream of the leak. Let's say the leak was coming out the aqueduct right here. They would go up a couple of 100 feet or yards to a hatch that they had built in the roof of the aqueduct. Open the hatch, which was usually about a 200 or 300 pound stone, like a big piece of slate sidewalk. And they would pour in a mixture of sand, sawdust, and cement, mixed into kind of a paste. Slowly drop it in by scoops or shovelfuls into the aqueduct, let it percolate south towards the leak, where it would disperse in the water, and enough of that cement mixture would get sucked into the water leaking out of the aqueduct that eventually it would stop the leak. It would get pulled into the cracks and voids. And so they could do that without shutting down the aqueduct and causing a water famine in the city. And they did that quite often after 1870. So it was an ingenious way of keeping the water system working, without having to shut it down. And all that cement that they poured in would gradually settle out to the bottom long before it reached New York City at the receiving reservoir, which was one of 2 reservoirs in Manhattan. The receiving reservoir was a big 30-acre rectangle built where Central Park is now. You might know it as the Great Lawn at Central Park, where all the ball fields are. And it was filled in not until the 1930s. My mother, who's 93 years old, actually remembers going down inside it when she was 7 or 8 years old. When they had just emptied it, there was a rickety set of steps, she said, built in, so people could get down into the dried-up reservoir safely. And she remembers running around in this big dusty field, not having a clue that it was the original reservoir that delivered water to New York City. And gradually during the next 4 or 5 years, it was filled in with rubble from all the buildings being built in Midtown. Rockefeller Center, Chrysler Building, pretty much everything, you know, in the 30s up to the 40s and 50s. Robert Moses was an early parks employee of the New York City Parks. One of his first jobs was to fill in the old reservoir in Central Park. And so today we know it as the Great Lawn. And then from there, the brick tunnel ended. The brick tunnel that these men had built ended at Central Park. Iron pipes went out onto Fifth Avenue and down 2 miles to 42nd Street. From 79th, which is where the reservoir was, between 86 and 79 in the center of the park. So the next 2 miles were iron pipes delivering it to the above-ground reservoir that we talked about. And from there, it had a chance to settle a little bit more, so no sediment was in the water. And then it fed into the pipe down at 14th Street where the city actually began. So it was a system that used a lot of the old Roman aqueduct properties to deliver the water by gravity, but they also had enough technology by the mid-1800s to use iron pipes as siphons, or to put the water under pressure. So when it went through the pipes, just like water in your house, it's under pressure. You open a valve or a faucet, water comes out because it's being pushed by all the water behind it in the system. And so the Romans did have pipes, but they were made out of lead, and they didn't put them under a lot of pressure. They continued to use gravity even in the lead pipes in Rome and other places where they built them in Europe. I'm going to get a chance to see the Pont du Gard in France, I hope, this summer. And it's basically a Roman aqueduct like this that built on 3 levels in the south of France that the Romans built over 2,000 years ago. And it's still there today for the public to see.
Correct me if I'm wrong,
Yeah.
but isn't a section of the aqueduct still used to deliver water to ossining?
Yes, the northernmost 2 miles of this old aqueduct are still in use for the purposes of delivering water to the ossining water treatment plant a little bit north of here and uphill. So it was closed down completely until the 1980s. In the 1980s, ossining needed an additional backup water supply for their own small reservoir, which was the only source they had at the time. And so they made an agreement with the city to put a valve in at the New Croton Dam, which is about a mile and a half, 2 miles north of Croton on Hudson, about 6 miles from here, and feed water into their water treatment plant at Indian Brook, which is a high elevation spot in Ossining where they gather their water. And they do the treatment of the water there. I've been on a few tours at the water treatment plant in Ossining, and the plant manager said that they can tell that the old aqueduct is leaking because they have a meter where they take the water from the Croton Reservoir in the new dam, and they have a meter at their treatment plant, and the two amounts never agree. It's always somewhat less when the water gets down to the treatment plant in Ossining. So even though it has stood the test of time for 175 years, it has developed a few leaks. The water you see under your feet is basically seepage from groundwater coming through the bricks, either from above the aqueduct or seeping in from the bottom. This is a fairly good flow right now, and it's because we've had a lot of rain recently. There are times when it will be just a slight trickle, and I've seen other times where it was an inch or 2 deep, after a hurricane. So it's basically just groundwater, all of which goes out the valve now, down into the Sing Sing Hill, through the opening in the wall over there.
Where?
And that opening, that faucet basically.
To the hole?
That faucet is controlled by
See what you want? That over there.
this gate, again, is an indication of how fast the Industrial Revolution proceeded.
Come closely down
It's
here.
one piece of cast steel that can be lowered on pulleys across the entire face of the aqueduct. It close off the movement of water to the south, and then let the workmen come in and inspect the bridge with the east and south. In the beginning, they just had little pieces of sheet steel held together with angle iron and little hand cranks, each of which would raise and lower a gate about 8 feet wide to open and close any gates on the aqueduct. So in a matter of 50 years, they had a steel industry that could build something like this by 1882. because the next group is coming down behind us, it's pointing off the northern end, and I'll show you another feature, another variation.
And Tom, another change is that we have no photographs of the original construction of the aqueduct because it was developed after the aqueduct was completed.
Correct. One of my major research requests is for an early daguerreotype of the aqueduct. Daguerreotype was the first invention by, forget his first name, but his last name was Daguerre. It's a Frenchman who developed the first photographic technique and introduced it in 1839 in Paris. The technique and the manual for producing daguerreotypes came across the ocean in a matter of weeks. And so while the aqueduct was still under construction in 1839, people in this country were beginning to figure out how to take photographs. Some very early ones exist, but none of the construction of the aqueduct that I've ever found. If you ever find one, please call me. If you look above your
I'll do that.
if you look above your head, you'll see the stone ceiling in its spine, where the aqueduct actually burrows through a high hill of rock. It would have been more difficult to go around and costly, more expensive to detour. So in this over 500-foot section, they dug right through the solid rock. They did it basically with picks and hammers and a big iron bar with a point on the end of it. And there would be like a team of 2 or 3 people who would dig away the rock doing this. You can see a little half circle scar of rock right there. And that's just half. That's the part that did not shear away when they finally pried it. The point on the end of the iron bar would be like a cross. And as the man holding the bar would turn it, a very small amount, with each hammer blow that the other 2 men were hitting on the other end of it, would gradually dig a hole deep enough so that they could load it with gunpowder, light a fuse, and run as fast as they could before it blew up. And it was very dangerous, dirty work. There is some documentation here that somebody died during the digging of this tunnel in an old newspaper clipping that shows up in the historical documents. They carried up the sides of the aqueduct walls here a little bit higher, as high as the top of the arch, which they knew the water would never reach any higher. And then they just left the stone in place where they could, where it was stable enough to last. And so it's looked like this since probably 1839, a couple of years before the complete aqueduct was finished, because they built the northernmost aspects of the northernmost parts of the aqueduct first. Let me see, what else? Oh, they used a special hydraulic cement. The cement between these bricks is probably the original hydraulic cement that was installed in 1839, 1840, and it was a special cement that had been developed probably around the time they were building the Erie Canal, 20 years before this. And coincidentally, the chief engineer who built the aqueduct also learned his engineering techniques and his knowledge of hydraulics building the Erie Canal as a 21-year-old axeman, chopping down trees for the surveyors all across New York City. And within 2 years, he learned so much that he became a resident engineer, responsible for building a 50-mile section of the Erie Canal himself. So by the time he was 25, he was an experienced engineer. Because the only engineering school in the country then was at West Point, everybody else said they had graduated from the Erie School of Engineering, if they had any skills in engineering whatsoever. And John B. Jervis could say that as well. He went on to build 2 or 3 other canals, one of which was a very important one for New York City and Philadelphia. It was the Delaware and Hudson Canal, which brought anthracite coal. The first time they had mined anthracite coal, which is a harder, cleaner burning coal, from Pennsylvania, around where Fort Jervis is now in the Delaware River, and named after him. It allowed that canal construction incorporated some fairly modern techniques, including the use of stationary steam engines to pull railroad cars up hills and then have them go down again on cable, so that they didn't have to tunnel through a lot of mountains to deliver that coal both to the Delaware River and to the Hudson River, where it was then shipped down to Philadelphia and New York for fuel, made a fortune for the investors, and cemented Jervis's reputation as a capable engineer, which I think is probably why they hired him about 4 or 5 years later to build the Brooklyn Aqueduct. He knew what he was doing. He was used to working on large projects, and and he had this probably Rolodex in his head of hundreds of contractors and people who had been experienced building the previous canals, and knew enough hydraulics to make water flow in the tunnel to make the whole thing work. Even though in the 1800s there were many naysayers and experts who could just hire a hall and say, it's never going to work, you're wasting your money.
But he was also a very fastidious administrator on all the subcontractors, and if a section of what work that they had done did not meet his engineering specifications, he would insist on being torn down and redone to his satisfaction.
Exactly. He would make them take different sections of the aqueduct if it had not been inspected according to his specifications. And so if the contractor tried to scam the work a little bit by not filling in the rubble on the outside or reinforcing it properly, and he couldn't tell that, it would come down and have to be built over again. So he was a very strict, kind of a Calvinist guy with one of those ramrods up his back.
But it's necessary because the weight of all the water in the aqueduct, if you did not consistently meet the standards, you'd have sections of the aqueduct subsiding, collapsing, and getting literally destroyed.
Sure.
The whole aqueduct, where it is not already on solid base rock, is built up with proper grade of rock, not any fill.
Exactly. Yeah,
Just like a highway.
There were 3 or 4 variations in the design of the tunnel for various geologic conditions they would find. Sometimes they had to tunnel through earth, and that's what this particular drawing depicts. So they could dig through earth with the proper kind of bracing around the tunnel, so that it wouldn't collapse and kill the workmen while they were building it. There was another for drilling or cutting through rock, which is this one. There was another cut and cover technique where they just dug a trench. If the grade of the aqueduct was, if the land allowed the grade to remain accurate. And the grade, by the way, was 13 and a half inches per mile. That was enough over the course of 1 mile, just dropping a little over a foot in elevation. The water would be all over the earth. So they had to actually engineer that grade. They didn't exist naturally on the kind of curvy ridges and hillsides where they were building the aqueduct. And very much like the Romans, he did pretty much the same thing. Used a lot of manual labor. Although no slave labor that right up to, I think it was all.
Well, they did use prisoners from Sing Sing.
Sing Sing prison did build its own water spur from the aqueduct into the prison.
Oh, they didn't use them on the regular aqueduct?
There's no record of it.
Oh, okay.
But then again, why would there be? If the contractor was making money, he probably wouldn't necessarily record that. No actual slave labor that we know of. And in fact, Tony Jervis was an anti-slavery proponent. He, along with many people in the North, believed that slavery was an evil that did not allow people the dignity of work and the rewards.
I think we need to move to the other end.
Yeah, we can move down to the other end, and I'll explain why the other end looks a little bit different.
This was a wonderful choice.
These are the tree roots that grew here last in the United Draft.
Do you have any questions? You can ask either of those questions, we'll try and answer. Well, I've been friends with the old aqueduct for 20 years, and I actually go to the keeper's house in Dr. Terry. That's near where I live. So, but you learn about the whole of the aqueduct, the weirs, the ventilators, the dams, the reservoirs. You have to learn it all.
Yeah,
It's all interesting.
that sounds like a lot too. There's so much detail that I didn't know about.
People don't realize that at the time, this was the most expensive engineering undertaking in the United States. More expensive than the Erie Canal.
Wow.
Yes.
Okay.
It solved a lot of problems for New York. New York was suffering from terrible diseases, cholera, typhoid, a lot of contagious diseases. Up to 1/10 of the population would die in a single epidemic of cholera.
Oh wow.
Yeah.
Yeah.
fires devastated New York City. The buildings were wood, and they didn't have a large source of water with which to fight fires. So
They didn't use water from the river?
you had to get the water from the river.
Well, they could have pumped it into tanks, maybe? I don't know.
No, they couldn't have pumped it into tanks.
Oh, they
They
didn't
didn't have steam
capacity.
engines.
Oh, okay.
1830s.
Yes. Okay, that makes sense.
Yeah, there's actually a reference, and one of the engineers who worked on the aqueduct was a Scottish immigrant named
Right.
Peter Hastie, and he was like a resident engineer, one of the four main engineers of the four divisions of the aqueduct, who wrote letters home to Scotland in the 1830s, describing his work on the aqueduct. And he kind of bragged a little bit about working on the most important part of it, and the part that was most difficult to build, and that was between High Bridge in the Bronx all the way down to 42nd Street. And that included the High Bridge over the Harlem River, which was not completed until 1848, which was so difficult to build. It involved a siphon between 135th Street and 125th, where there was a deep valley called Manhattan Valley, and it would have been a 200-foot high aqueduct if they had built it that way. So they put in siphon pipes going down the valley, up the other side of the siphon, and then the reservoir in Central Park, and then the 42nd Street Reservoir. So all of those were components that Peter Hastie was in charge of. And when he wrote his letter home in the 1830s describing his part in building the aqueduct, you could tell he was bragging just a little bit. And then also, his uncle James Scott, then shows up after 1842 as one of the keepers on the aqueduct here in Ossining. If you look at the census records from 1850 and 1860, James Scott, the family who he had written to in Selkirk, Scotland, he was then James Scott watchmaker, Selkirk, Scotland. And so he was you could tell from the letters that Hastie wrote that his Uncle James was fairly well educated. He had the opportunity to go to school. And so when he got here, I'm pretty sure Hastie got him a job on the aqueduct. So some old-time nepotism kicking in. Even back then, who you knew counted. The reason this part of the aqueduct is lined with cement is that it was rebuilt in 1913. Early in the 20th century, a little over 100 years ago, the bricks and the metal iron linings that were built over the arch crossing the Sing Sing Hill had probably worn enough that it had leaked a little bit. And one thing they wanted to prevent was leakage in this part especially, because it could have threatened the entire bridge. So they demolished the brick and iron plates that had prevented leakage and cast it with basically rebar and poured cement, which was a technique they were using in the early 1900s. And you can tell from the shadow, if you look down the tunnel, the shadow reaches up to about 6 feet. And that's about the level of the water that they would have allowed in the tunnels after 1913. Not up to the roof, not to the spring of the arch, but a little bit higher. So probably 80 million gallons a day came through here. And at that point, this particular conduit was a secondary source for the growth of water. The new road and aqueduct having been completed in 1890 to deliver 300 million gallons. Again, that was brick lined. But they had the advantage of dynamite and steam power and compressed air drills driven by steam engines, so that they could dig much deeper shafts, get the tunnel away from the surface contours. So instead of being 41 miles long, the new Croton Aqueduct only had to go 31 miles. So that there was that much of a combination of curves in the old aqueduct that it had to be 10 miles longer, conforming to the contours of the surface of the land. And so all modern aqueducts after that, because of the technology they had to build in straight lines far underground, were built pretty much in straight lines, keeping down the mileage and the amount of concrete and the amount of labor. There's one journal that I found, an engineering journal in New York, described the construction of the Catskill Aqueduct in the early 1900s, when the Croton was no longer sufficient to supply enough water to the city. And it said that under Delancey Street in New York City, they had to dig a shaft 700 feet deep. So almost the height of a 70-story building.
Wow.
That much straight down under Delancey Street. And there were photographs of the bedrock they finally found down that deep. And it's Manhattan schist, and that is sometimes with a little with little gradations of limestone or marble that they had to dig through to find and they had to go down that far on Delancey Street to find solid enough rock to build a water line, and then line it with cement anyway.
I always thought that all of New York City was bedrock, and that's why they've been able to build the way they did. But they found a place where
It is
it was not.
mostly true, but there are places where the bedrock just falls away and you've got to go down 700 feet. And I think this in Chelsea, in the 20s and lower 30s, I think there's another area where the bedrock drops away, or a lot of buildings are built on pylons. Or just
One
very.
in Chelsea is rubble now, but that would have been a little later, probably.
Yes, as they built upwards from downtown.
Tom, this granite here, what kind of granite is it? Is it schist or gneiss? Oh.
I don't know.
Oh.
I call it nice schist.
Nice.
Because I don't know the difference between the two bedrocks. I just quote both of them as the standard bedrock of New York City, which continues up the Hudson River Valley, basically the same stone. You know, and I live just north of here in a small village, and there are outcroppings on the surface of marble. And it's limestone, which is very soluble compared to granite. And during the Ice Age, a lot of it was worn away and exposed, as well as the harder rock.
So you know where the Aqueduct Trail runs into 9A, and then you have to back up and go down a road and go around and then go around GE?
Yes.
Did the aqueduct go through the property that's now GE?
It does.
Okay.
Yeah.
And so somehow they didn't have to have a variant so that people could go right
The
through?
aqueduct was an abandoned state property for.
Oh,
For about 25 years, it was shut down, and before it became a state park in the 70s,
okay.
various Sharpies like GE knew how to get their hands on the property. The Sleepy Hollow Country Club also does the same thing.
And that's why also a lot of the village parking lots are on top of the aqueduct and.
Yeah, exactly.
Okay. Yeah, no, it gets very sketchy through ossining to follow it on.
It does. If you just follow on Spring Street, continue on Spring, going south.
No, I did it.
Yeah, did you see the
They
ventilator?
told you how to do it.
Did you see the ventilator tower outside the grammar school?
No.
Oh, if you continue on Spring Street,
Okay.
the most ornate, pretty ventilator tower in the system is right here in ossining. And it was built by T.J. Carmichael.
You're not talking
To
about
describe
north
his
of
name.
here, you're talking south of here?
Going south, yeah.
Oh, okay.
Nelson Park?
Yeah, by Nelson Park, exactly.
Yeah, yeah.
There's a little stone tower, which has some nice shapes and cuttings on it. And so T.J. Carmichael, the contractor, thought enough of his handiwork to carve his own name in it and a date. And he had previously been an employee of Jervis, scouting out locations for quarries or suitable stone for building for the aqueduct. So he probably saw at some point that rather than getting city wages, he could become a contractor and make a lot more money. And so I think TJ was a smart guy at the time.
So there's also a very important reason why it must always be air at the top of the water. And that is if the water should fill up completely, you'll get what's called hydraulic knock, which you probably may have noticed if you have a turn off the valve and you get a bang on the pipes.
Bung, yeah.
Yeah, well, and it can repeat. So that is very, very destructive because water propagates that force everywhere. And
Like a wave.
yeah, well, like repeating waves. And it's very destructive on the masonry environment. So it's very, very important that there always be air. And that's one of the purposes of the ventilators, was also to ensure that there would be air.
Okay, yeah.
Also providing access, but
Yeah, and equalize the inside and outside air pressure in the tunnel. Air could get in and get out as the water level rose or fell, as they modified the environment or emptied out the water for inspection or revision. But there were times where the reservoirs in New York City would run down to a precipitously low level, and the water pressure that was enough to drive water up 5 stories in any building in the city would begin to drop. So first, the people on the 5th floor wouldn't get water, and then the people on the 4th floor wouldn't get water. And by the time it reached the 1st floor, you knew you were in trouble. Because the water pressure had dropped to a point, and the aqueduct had to put back into operation. And when they did open it up, it took about a day to fill up the aqueduct. So that being the case, the workmen were always working very quickly. There are some really interesting stories involving rowboats in almost every generation of aqueduct construction, where the rowboats were used for inspection purposes. The first one is with Jervis himself in 1842, and all his lieutenant engineers going in a rowboat they named the Croton Maid. I think it was probably a shallow draft rowboat with just, 8 inches or 10 inches of water in the aqueduct. And they rowed the rowboat from the original Croton Dam, about 7 or 8 miles north of here, all the way down to Highbridge on the Bronx side of the Harlem River. And that they had to end there because the aqueduct bridge had not yet been built. They had a temporary siphon at that point, and they couldn't squeeze through that bridge.
Well, they would have drowned.
They certainly would, or been really compressed. So that was the first rowboat story, and when they were building the new Croton Aqueduct in the 1880s, there's a couple of stories by newspaper writers describing their tours of the almost complete and then complete aqueduct with the engineers. And they read like Indiana Jones stories, with water rushing through, and if the engineers up front hadn't put the gate in front, we'd be washed into the siphons. And it was very well written, and they're worth a read.
And also, one of them dropped their hat in the water and had to retrieve
Trying
it.
to fish it out, yeah, exactly. Yeah, there's lots of talk about how they brought beer and sandwiches with them on their rowboat trips. But very well done. I mean, really, probably slightly over-dramatized the
Is
story.
this on
from
the,
the
are
journalist
they
point of view.
on the internet that you find this?
You
or
can
you're
find them
gonna-
in various ways. Some of them are on the internet in engineering journals. I found one account at the Westchester Historical Society, and just a series of, a photocopy page of an old newspaper clipping, and that's probably the only form it exists in.
Right.
There are a couple of the newspaper accounts. I don't have the references with me. I'd be glad to.
No.
Glad to tell you what they are.
You said you'd been reading from a letter from someone home about the aqueduct when we started.
Oh,
When
Hastings.
we joined the Hastings? Is that it?
Peter Hastings.
Oh, Hastings.
He was one of the 4 resident engineers
No,
building
at the
that.
very beginning at the top.
Oh, at the Fayette Bartholomew Tower.
Tower.
Did you hear the quote?
No.
I'll be glad to read it again.
Sure.
I love this quote. Actually, how are you? How's your reading out loud voice? Are you good?
What a great name.
Yep. FB Tower.
Water being led into the 42nd Street distributing reservoir on July 4th. At an hour when the morning guns of the rout but few from their dreamy slumbers, and ere yet the rays of the sun had filled the city dome, he stood upon the topmost wall of his reservoir and saw the first gush of the waters as they entered the bottom and wandered about as if each particle had consciousness, and would choose for itself a resting place in this palace towards which it had made pilgrimage. Or I fancied I could recognize the water nymphs of the Croton come from their rugged caverns to enjoy the refinement of city residents. Sounds like Washington Irving.
Yeah. You have to remember that he was writing to his girlfriend, his paramour,
Oh, okay.
and Helen Phelps, who resided then. Well, he was in New York. She was up at the female seminary in Troy, New York. And so that's just a quote, a sample of the letter. And the other part of the letter, he's trying to get her to come to New York to visit him and stay in his apartments. So I think they may have gotten married eventually. Although FB Tower did not live a long life. A lot of these old engineers worked themselves to death on this project, Tower being one of them. They worked 6-7 days a week, 12 hours a day for 5 years in a row. And, when they were young men when they started and old men when they finished, simply because they worked so hard to get these projects built. There were no OSHA rules at the time, no hard hats, no safety belts, no oxygen sensors to tell you if you were walking into a dangerous situation.
And they were the guys at the top, just think of the workmen.
The workmen probably suffered a heck of a lot more.
Yeah.
There were some fatalities, although we don't have a record of the number who built the aqueduct.
But I'm just thinking, loss of hearing, blindness.
Oh, sure.
You know.
Stone falling on your head.
There was no caisson work here though, Tom, was there?
Not in the Croton Aqueduct, no.
That's dangerous.
They built a few, not caissons.
Siphons.
No, what are the like a empty wooden vessel with a big chamber in the Harlem River.
Okay, like,
Copper dams. They built a number of those in the Harlem River.
that makes sense.
And
For the
they had
piers,
to pump
put in the
water out
piers.
of them.
Okay.
And then they had to basically build the foundations for some of the piers
Right,
of the High Bridge Aqueduct within those coffer dams. And that's what they laid the temporary siphon pipe on while they were still building the the High Bridge.
Oh, okay.
To deliver water between 1842 and 1848. It's just a temporary siphon down the hill on the Bronx side, across the river in the height on the level of the river, and then back up, and then fit it back into the brick tunnel that had been built at Manhattan.
Is the High Bridge open now?
It is. It opened up about a year and a half ago.
And you can walk over it?
You can in the daytime hours. If you enter High Bridge Park at around 168th, 169th Street, you can see the water tower in the distance.
Right.
When you're near Amsterdam Avenue. Just go in back of the water tower.
Yep.
To the level. There's a steep flight of stairs, which itself has been rehabilitated.
Okay.
And then you'll end up right on the level of the High Bridge, and you can cross it in the daylight hours. I like to call it the Uptown High Line. This kind of serves that purpose.
We call the Sing Sing Kill walkway down here the low line.
It is.
You ever walk down there?
You can't go past here because.
No. Have you ever?
Oh, have I ever? No. I brought a couple of school groups in here, and a couple of the kids like to jump the fence and run down.
When I was a brand new patrolman here 30 years ago, they made me check it before they closed the stuff, before someone was stuck in it.
Oh, how far down can you go?
You can go just beyond Main Street. And I was okay walking down, but when I turned around and saw that pinpoint light, I was like,
Yeah.
I was not happy.
Yeah. Hook that extra batteries for your flashlight.
So you were patrolling here in Ossining?
I was.
This is Scott Craven, local historian.
Well, a local guy
You
anyway.
walk down
Guy
this
knows a
way,
lot about
walk
it.
down this way, how far, do you know?
Beyond Main Street,
Okay.
so it's a long ways.
Is there a plug or a gate there?
Yeah, that's me.
Okay, there's the gate this way too?
Yeah.
Okay, because we see that in the video that the New York City TV station produced.
And Ossining is still the only municipality taking water from this.
Yes, yeah, we talked about that.
Yeah.
Still taking water.
And they just finished doing Indian Brook Reservoir, and they're just starting to fill it up again.
I took a crew down there, a tour. Oh no, I saw something online. That's what it was. They had emptied it. And they were rebuilding the earthen dam.
They're letting it fill up again. They say it's going to take about a month till we're back in business.
Oh, for the brook to fill it up naturally.
Yep.
Yeah, unless it rains. There's a great story about the New Croton Dam, which they had almost completed in 1905. They still had 20 or 30 feet of elevation of stonework to add to it. And there was such a heavy rainstorm in 1905 that the reservoir filled up to within 5 or 6 feet of the top of the stonework. And they were afraid that the water might overtop the incomplete dam. They thought that it would take a year for that reservoir to fill up. And in only one rainstorm over a long 2 or 3 day period, it almost filled up the reservoir.
People forget, the New York City area gets more rain every year than Seattle does. We get, Seattle
40
gets,
something inches a year.
we get 42, they get 40.
Really?
The Croton River is 372 square miles of watershed. That's a lot of land
That's a
for
big
42,
area.
and that's a lot of water we get.
And they collect almost every drop.
Yes, they do. I mean, if you look what comes out of the bottom of the New Croton Dam, they have sucked every little last, drop out of it, but,
I have a picture here that most people haven't seen, which is some of the work they've been doing for the past 2 years, putting new machinery in the New Croton Dam. This is one of the gatehouse, the effluent gatehouses. They removed the 111-year-old equipment, which was all cast iron and hand-cranked machinery. One piece
That
of
looks
it
almost
was
too small. I mean,
Well, these are 2 of 4 effluent pipes that are about 4 feet wide each.
okay.
And then to that, they were adding these big effluent valves, which weigh about 12 or 14 tons apiece. The old ones they took out were large ovoid shapes, and they weighed even more than these.
if people, Tom's talking about the New Croton Dam. The old Croton Dam is underneath the water.
Yes, I know that, yeah.
So it's,
Yeah, we
people
have
say
a-
they get confused by the New Croton Dam. How could that be new? It's 100 years old. Well, it is.
We have a shot I got from the Westchester County Historical Society
Of the old Croton Dam?
when it was uncovered in 1955.
Right. You can see it at low water in August. If they lower the reservoir to kill the weeds, sometimes you can see it if the water's clear enough.
Yeah, I've never got a good look at it, so.
Not a good look. No.
Now, is it roughly under the new span?
Under the bridge, yeah.
Under the bridge, yeah.
Yeah, I think the bridge actually straddles the dam at kind of an angle.
I think you're right.
You're right.
Where is that?
And of course, talking about overtopping dams, unfortunately, the original dam for the old Croton Aqueduct was overtopped
It was, and then Jervis did some things to it that people still use in dams today. With the reverse S curve in there,
Right.
he makes sure that
On the spillway.
I mean, there's 2 earthen dams in Ossining today that have been here 100 years. But look what happened in California. The largest earthen dam in the world in April almost went. Because if you put water over an earthen dam, it melts like butter.
Yeah, Orville.
Orville, that's right.
Yeah, I remember watching that because it was very
And it's
touch and
gonna
go for
cost
a few
them,
days.
it's
Yeah, it
gonna
really
cost them billions of dollars to do all the repairs.
Well, that's one of the things they did in the Indian Reservoir is they increased their ability to dump the water so it doesn't overtop the dam.
Which dam?
One for Ossining. Indian Brook Reservoir was stuck in there over 100 years. And you know what they found when they let it down? Is a campfire at the bottom. Campfire, like a ring of rocks that the workers in the 1890s.
Always interesting to find out. I can't find a picture of the old dam.
So Tom, have you mentioned what Tom?
Tom, take care.
Nice meeting you.
Thanks for coming in.
When you were.
Oh, I may have left
It
it
may have,
upstairs.
it may have been with that guy. Yeah.
You may have mentioned what the problems were that
You wanna-
was addressing.